Welcome to this webinar of Kistler on the topic of improvement of traffic data on roads and bridge infrastructure with KiTraffic Statistics. My name is Christoph Klauser and I am the product manager for road and traffic products at Kistler. In this webinar, you will learn about traffic data collection today, what is the purpose of traffic data collection, what existing infrastructure and technology is used, what are the benefits and challenges of collecting weight data, especially with existing technologies. And in a second step, I want to show you how you can improve your traffic data with the KiTraffic Statistics WIM system, its key characteristics, its integration into existing infrastructure, and an outlook to a pay-for-data model. In a third step, you'll learn about bridge health monitoring with this new WIM system, KiTraffic Statistics, and at the end I'm going to show you the field experience of already deployed systems. Let's start with traffic data collection. In traffic data collection, 4 parameters matter. Volume, how many vehicles are driving on the road, classification, what kind of vehicles are there, weight, what is the axle and gross weight of these vehicles, and the speed of the vehicles on this road. These 4 parameters are essential for many topics in road management. Design of pavements and new roads rely on it. Maintenance planning, as well as operations and safety of road, use available traffic data. Furthermore, assessment of road performance, financing, or engineering economics are reasons to collect all 4 parameters of traffic data. There is a lot of technology out there to collect traffic data. These 2 tables of the FHWA Traffic Monitoring Guide show different technologies available. On the left table, we see different technologies for counting vehicles versus counting axles. There you can use inductive loops, magnetic sensors, video detection systems, even acoustic or ultrasonic sensors, radars. And for the axle sensing, things like fiber optic technologies, bending plates, load cells, piezo and quartz sensors are available. Looking at the table on the right, we see that for classifying motorized vehicles, also there are different technologies available. They can be based on axles or based on vehicle length for the classification. There again, we have for the axle-based classification, infrared or radar or piezo or quartz or fiber optic technologies, bending plates, load cells, etc. And for the length-based technology, there's a lot of loops or video detection or radar-based systems. So having the overview and the conclusion on what technology fits best for my purpose is not that easy. The only thing that you should keep in mind and know there is you need a weigh-in-motion system to collect all 4 parameters at the same time at one side: volume, classification, weight, and speed. A large number of different technologies to collect traffic data is out there. Not all of them is able to collect weight data, and here I want to highlight why it is important to collect weight data with traffic data collection. The traffic load data is used on the one hand side for pavement design. The MEPG, Mechanistic Empirical Pavement Design Guide, requires input on the traffic load spectra. Also, the more traditional AASHTO design requires the ESAL values, the equivalent single axle load values. In the pavement maintenance, it's important to know the traffic loads to select the right treatments and intervals for the maintenance works. To improve your road network, you want to determine the cost of congestion and see the benefits of new constructions and strategies. There it's also helpful to know where your weights are on the road. And of course, at the 4th point, you want to have a fair cost allocation to determine the relative cost of responsibility of the different road users. And last but not least, especially in these times where a lot of bridges are old and some of them failing, this input is very, very helpful to do the design and the maintenance and the planning of the remaining lifetime of bridges. We all agree weight is an essential part of traffic data. So why are WIM sites so rare out there? The answer is there already given in the traffic monitoring guide of the FHWA. WIM equipment is supposed to be expensive to install and also to maintain. So we all face the challenge, how can we get more weight motion data? We want to have a good enough accuracy in a given road. We need to make the investments within our budgets. We want to keep maintenance cost as low as possible and to achieve longest sensor lifetime in the road to get the best total cost of ownership. And Kistler wants to introduce here its new solution called KiTraffic Statistics. KiTraffic Statistics is especially designed for traffic data collection. It provides volume, classification, speed, and weight information of the traffic. Its WIM accuracy meets the requirements of the ASTM Type 1 and Type 2 systems, saying gross weight between 10 and 15% accuracy. It allows investment in WIM sites even with limited budget. It has an optimized price-performance ratio, especially for the traffic data collection application, and as all quartz-based WIM systems, it does not require any maintenance. The reliability of the KiTraffic Statistics system ensures even lowest lifecycle cost. The subsurface installed Linear's compact sensors ensure longest lifetime in the road, as the sensors are not directly exposed to the traffic outside the road. The quartz sensors itself, they are very stable over time and in environmental conditions and load ranges, though they don't show any deterioration. And the robust electronics inside the cabinet ensure a permanent uptime. KiTraffic Statistics consists of 4 components. Linear's compact subsurface sensors are installed on the road. They have an optimized cost-performance ratio, especially for the traffic data collection application. These sensors are installed 20 mm or 0.8 inch below the road surface, as you can see on the picture on the right. This subsurface installation allows longest sensor lifetime in the road, and it enables installations on roads with ruts. The second major component is the WIM data logger. It processes sensor signals to precise weight and speed information. Its algorithms are optimized for the Linear's compact subsurface sensors. Low power consumption of the WIM data logger enables installation even on solar-powered sites. In addition, it is flexible to adjust vehicle classification schemes to local requirements. This means your local scheme can be applied in the WIM data logger for the vehicle classification. The WIM data logger can be accessed via a web-based user interface. This means no hardware needs to be installed on your local PC. You only need a standard web browser to access the WIM data logger. On the WIM data logger user interface, easy workflows for setup and calibration facilitate the commissioning process of a WIM site. Data of the data logger is available on multiple interfaces, which are explained on the next slide. And last but not least, all additionally required electronics like loop cards and power supply come on a pre-wired DIN rail. This pre-wiring makes installation into a cabinet quick, easy, and free of potential errors. KiTraffic Statistics can be easily integrated into existing infrastructure. For the hardware integration at the roadside, you only need to provide power and network connection and a little bit of space in the cabinet. For the data integration, the WIM data logger offers three different ways to retrieve the data. Via the graphical UI, data can be easily accessed or exported in a CSV format. In an automated way, data polling via a REST API is possible in a CSV or a JSON format, and data streaming, so push communication from the site to your server, is also possible via WebSockets, so Ethernet. This data is then available in JSON format. In the last few years, a new trend appeared: paying for traffic data instead of buying the traffic data acquisition systems. This has a lot of benefits for the end user. You don't need to do any upfront investment, and you have a maximum budget control, as you only pay if you receive good data. You can focus on the data evaluation and on managing your roads with the traffic data provided. The manufacturer or provider of the data takes care that you get the good data. Of course, in this case, it is very important that you work together with a reliable partner and with durable technology. And in case there are any issues on site, of course, rapid reaction times and fast support is needed. And therefore, a KiTraffic Statistics system with its reliable sensors and long life technology paves the way to enable this pay-for-data application. In the next couple of minutes, you will learn how KiTraffic Statistics improved your data for bridge health monitoring. In many countries around the world, the health and status of bridges became an essential topic throughout the last few years. There are two main reasons why bridges fail. On the one hand side, there is fatigue, and on the other side, there is corrosion. For both reasons of bridge failures, there are certain countermeasures in place, of course. For fatigue, it is important that you know all your loads from traffic, but also from wind, earthquakes, and so on, which act on your bridge. Then you need to precisely understand how these loads impact your structure, and then you can repair or improve your structure over time if you detected certain weaknesses there. In case corrosion is a problem on the bridge, you need of course to detect this corrosion on time. Then you can start repairs and you can start preventing corrosion by certain sealings, coatings, or using stainless steel, for example. Measurement technology from Kistler enables 3 different ways to support bridge monitoring. On the one hand side, number 1 indicated here, you can monitor the real traffic loads on your bridge with KiTraffic Statistics. On the second side, the second option is to identify and to detour heavy vehicles with the KiTraffic Plus system. This means weighing them and tell them you must leave the bridge, you need to take another route because you are too heavy for this bridge. And last but not least, Kistler offers sensors to identify changes in the structural health of the bridge with accelerometers. So you can do modal analysis and see if the behavior of a bridge changes over time. What is the benefit of knowing the real traffic loads on bridges? Each country has its own national standards to assess bridge health. The basic idea of these standards are very similar: periodical visual inspections and recalculation of the remaining lifetimes depending on these findings. The differences between these national standards are mainly in the intervals and the calculation methods, but the overall idea is the same, and periodical fatigue calculations are done everywhere around the world. If no real traffic load data is now available for such fatigue calculations, conservative models and assumptions are taken into account. In this case, the resulting remaining lifetime is shorter than actually necessary. These assumptions of course make sense to prevent catastrophic events, but having more realistic results with real traffic load data does not increase any risk. It only helps to avoid unnecessary usage restrictions like weight limitations. In case weight limitations are necessary, the WIM system even can help to be used for enforcing these usage restrictions. Here again, I want to highlight that traffic load data acquisition must not be expensive. Taking the new KiTraffic Statistics WIM system into account, it can be very cost efficient to collect long-term traffic load data on bridges and therefore replace the data of load estimations with real traffic load data to get more precise results of your fatigue calculation. This overall improves the reliability of your fatigue calculation, and in many cases this increases the remaining lifetime of the bridge, or it avoids even to implement any usage restrictions, or if you really need to apply usage restrictions on your bridge, you already have some measure available to enforce this, so to see if there's actually the implemented weight limits followed by the bridge users, or if you need there more enforcement capabilities. In the next chapter of this webinar, I would like to focus on the field experience of this KiTraffic Statistics WIM system. The few highlights of KiTraffic Statistics installations include both applications, traffic data collection and bridge health monitoring. On Osman Gazi Bridge in Turkey, the traffic load of vehicles is monitored with this WIM system. On the second example, the El Carrizo Bridge in Mexico, this bridge was rebuilt after a severe accident a couple of years ago, and now on the new bridge, trucks which exceed a certain limit are not allowed to cross this bridge anymore. Kistler WIM systems identify these overloaded trucks and help to detour them. On a third example on a bridge, I'd like to talk about the Wuhan Bridge in China. There, the WIM system is part of a large and complex bridge health monitoring system with lots of additional sensors. Weight data there is used among many other parameters to monitor the bridge status with a digital twin, an FEM model on the bridge. And last but not least, several sites in the US already provide data on volume, classification, speed, and weight to the Federal Data Collection Program. Now let's take a closer look at what kind of data you can get out of the KiTraffic Statistics system. On the first graph on the top left, we see traffic volume per hours in a 3-month comparison. In the 3 different lines, we see the traffic volume every hour throughout the day in 3 different months. This means we can see certain trends, how this traffic volume evolves over time. We see here from the side that in November the overall volume was lower than in October, and in October was again lower than in September. But the general pattern between a certain peak in the morning hours around 7, a decrease at 8 a.m. and then the constant traffic until about 5 p.m. then decreasing over the night is clearly visible from this volume data. Another view on the volume data on top right shows the traffic volume per hour of all Saturdays of the data which was used for this graphic here. We see here that the peak on the Saturdays is similar, but we have a peak later on at 10, 11 a.m. Then there's a decrease at noontime, so the traffic pattern on a Saturday looks a little bit different than the overall. We can compare, of course, all other weekdays, the certain traffic patterns. In the graph on the left bottom side, we look at the traffic volume per vehicle weight. This means we had here in our data set a total volume of 227,000 vehicles, and the large majority of it, 78%, were vehicles below 3.5 tons. And there is about 6% between 8 and 18 tons, the yellow part here, and of course smaller parts here in different weight areas. These bins of course can be created as you want depending on your needs of the application. Another interesting graph you can derive from the data, for example, is to see what is the total weight on every day. We took here 1 month of data. It was a December data. So we see here that if we sum up the weight of all vehicles, we clearly see on the 5 weekdays we have more or less same weight amount on the roads, whereas on the weekends we have significantly lower weights. And here the interesting part about December is with the public holidays and the working days in between, we see here a nice indication on how much weight is on the road in this time frame. Let's continue with a few more examples of data that you can derive from the KiTraffic Statistics system. On the left side, we see a graph of volume per number of axles. This means how many axles did the vehicles have that were counted by this WIM system. We took here 78 days of data into account. We see one axle vehicles, of course, they were 0. The large majority of the vehicles were 2 axle vehicles. A few with 3, some more with 4, and the second most number of axles of vehicles is a 5 axle vehicle that was counted on this side. In the middle graph, we take a look at the speed bins at this side. The same data set was taken into account for this graph. We see here the peak around 70 kilometers per hour of speed at this side. We see that the minimum speed is somewhere between 30-35 kilometers per hour, and only very few vehicles were driving faster than 115-120 kilometers per hour. The last graph, as an example that I want to show here, is the vehicle classification. I took again here the same data set of 1 month where 227,000 vehicles were counted, and we checked for vehicle classification. Most of the vehicles again were classified as a class 1. These are mainly the 2 axle vehicles here. It's the 72%. And then the other classes were measured with certain numbers in percent, 4 to 7% of the other classes. As I indicated some slides before already, the classification scheme within the system can be set to your local classification scheme. So let us know what's your vehicle classification scheme looks like, and we can implement it in our electronics to make the right statistics for you. All the examples shown on the last 2 slides are just examples on what you can do with the data and what information you can get. There's a lot more potential evaluations you can do with the data, but that's too much for this webinar. So let me summarize the last few minutes on the KiTraffic Statistics system. This is a new WIM system to collect comprehensive traffic data, including volume, the classification, speed, and weight. It lowers your investment in WIM systems and helps to enrich your traffic data with weight information where you only had volume, count, classification, and speed before. And in addition, it increases the remaining lifetime of many bridges by acquiring the real traffic loads and using real data in your calculations. To sum it up in one sentence, I would say KiTraffic Statistics is the key to sustainably manage your roads and bridges you're responsible for. In closing this webinar, I would like to make you aware of another WIM system from Kistler. It's called KiTraffic Digital, and it will be launched this year. This is really the most accurate WIM system you can get in the world. It has a digital WIM sensor installed in the road, which evaluates every single quartz separately and therefore enables calibration of each single quartz disk inside the sensor separately, which allows a lot of new innovations and features for example, reliably measure vehicles in all kind of driving maneuvers in a free flow traffic, like lane changes, make more specific calibrations on the road, and even detect single, dual, or even flat tires with exactly the same sensor installed in the road, no additional hardware needed for this. This WIM system is intended for weight enforcement and enables the highest rate of enforceable vehicles measured by the WIM system. If you're interested in the KiTraffic Digital, please go on our website and visit kistler.com/WIM-reloaded. I hope you learned a lot on our new technologies for traffic data collection and bridge health monitoring in this webinar. Now I want to say thank you for spending your valuable time with us and wish you all the best for the coming times and project in this field.